PowerPoint screen, and today I will talk about this paper called Imagenet-Trained CNNs are biased towards texture, and increasing the shape bias improves accuracy and robustness. So this was presented at a major conference. It's called ICLR. I don't remember the full form of ICLR, sorry. This is just presented last week. This is one of my favorite papers from this conference. Just all the yeah, and if you have any questions, just stop me, okay, at any time. The more interactive it is, the more fun the discussion will be. Okay, so just my acknowledgements. I basically used his talk, and the first author is Robert Guerros, and I use screenshots from his talk and also from his blog and from these two courses. Um, if you are interested in CNNs, the Stanford 231N is one of the best convolutional neural network courses. I think now we have, okay, let me see if I can mute. Let me see, there's some message on the chat. Okay. Yeah, anyway, getting back. So if you're interested in CNNs, they have different versions of this course, and all the material is online. Um, the videos are on YouTube, um, and they have it for 2016, 17, 18 too. So, and this is just an older, more traditional course where it's doing texture analysis. Okay, so the title of this talk is, we know CNNs are doing really well. So for example, in object recognition, we have in the ImageNet competition, the error rate is below 5%. Okay. So one of the things this paper is trying to understand is what is the CNN learning? Okay. Why is it doing so well? Is it looking at the shape of objects, or is it learning, focusing on the texture? Okay. So just to define image texture, here you see three examples. So you have some, um, so image texture gives us information of the pixels or intensities in an image. Okay. And you can have, say, artificial texture, like say this image of bricks, or you have, you find this in the nature too, like say the skin, the fur of a cat, right? Or the fur of a dog, or the skin of any animal, or basically that's the general idea about image texture. And if you just do a Google search on, so before the deep learning era, there were a lot of image processing methods to find image texture features. Okay, so there's both. They're looking at how frequently, say, image intensities appear, how periodic things are. So this is a very periodic pattern, or it could be just some random texture. Right? So there's a whole bunch of literature on image texture features. Okay. So far, like if you ask the question like how do CNNs recognize objects, uh, the standard explanation we've got from various sources is, oh, so layer 1 you have edges, layer 2 you build more complex shapes. Um, so in this example, this is from the author's talk. So he says layer 3 you have like a door, um, and as you build up layers, you get more complex objects. So say layer 5 has the house, and we have something similar in different courses too. So this is showing the features in different layers of VGG. Yeah, this is from the CS 231N course. Um, and then the author has one more example where maybe it's more easier for me to describe this idea is um, that the earlier layers have some basic shapes, and then here layer 3 is getting to a wheel, and then layer 5 you might get to the complex object. And this is from a paper in 2015. Okay. Um, there's also some uh, so people are trying to think that, oh, is CNNs recognizing objects as how humans recognize objects? But nobody knows that for sure. So if the so you see these three images, right? Do you see any object in these three images? Uh, you can type or say it in the chat. Yeah. So this is just a texturized version of. Okay. Okay. Great guesses. So this looks like like just something, but I'll show you the original image from which these are created. So these are created from the dog image. Okay. And when I saw this example, I was quite surprised. Like, if I see these three images, I can never say there's a dog. But the CNN is able to say that, oh, there is a dog in all these three images, which was quite surprising. Okay. Um, okay. So this is the main question the authors try to answer. Okay, you have an image of a cat, you have the texture, which is the local features, and you have the shape. So what is the CNN trying? How did it recognize the object? Okay. And there are some papers that said that, oh, CNN is focusing on the texture, and so there was like conflicting papers. So one set of papers like, no, CNN is focusing on shape, and the other was like, no, CNN is focusing on texture. Okay. So this whole objective of this author's paper is, can we figure out which is it? Okay. Is it shape or texture? Um, okay. So any questions so far? Okay, I think I can. Okay, great. So, so what the author did is, and this is also a nice way. Like, I like the scientific contribution too. He's like, okay, I want to answer this question. What is the deep learning experiment I'll set up? So he took images from basically ImageNet. So he took the cat shape and the elephant texture, and then just combined it into this new image, basically using standard style transfer methods. He gave It's a method from 2016. So here's the first result from his work is basically when they take the original image, the texture image, the cat image, or the new modified image, you see the CNN is completely confused, right? It thinks it's an elephant. Okay. So they did this on thousands of images, pretty much like every image in ImageNet. Okay. And now they also do like um, what it's called is they also did human experiments. So when they created these thousands of images, they showed it to a standard CNN, and they also had like a bunch of students or a bunch of people in the lab look at the images and try and say whether it's a cat or an elephant. So what this means, the red is the results for the humans. So no matter what you did, um, the human observers had a strong shape bias, so they can look at it and say, oh, this is a cat. Okay. And on the right hand side, you see what happens to like a ResNet 50, one of the most popular CNN architectures, is that it has a very strong texture bias. So um, it's getting misleaded by texture. And so the question might be, okay, there's only ResNet 50. How about like GoogleNet or AlexNet or all the other architectures? Um, So they all, one of the findings reported is that all of them have this big, like a texture bias. Okay. So they are more focused on the local texture rather than learning the shape. And the authors say maybe it is because it's easier to learn the local texture than to learn the shape, which might be more complex. Um, okay, so that was their first conclusion, was that they mostly recognize the CNNs mostly recognize textures and not shapes. Okay, so now the second question is, can we can we make CNNs more have a bigger, give shape a bigger importance, and how would you design that experiment? What would your training set be? So the idea is I think it's a clever idea. He developed something called there's a new data set they made. It's called stylized ImageNet. Okay, so this is the original image on the left, and what they did is they replaced the texture with random stuff, right? So you're basically getting rid of the texture, but in all these images you can see, in most of them at least I can say that there's a dog present, right? And so they've created this stylized ImageNet with random textures, and this data set is available online. Okay, so I think that they made it public. Um, any questions so far? Yeah, by shape, uh, by shape we mean the shape of the object. Yeah. So whether it's an elephant or a car, or let's say all cats have some specific shapes. Um, yeah, kind of LSD. Yeah. Yeah, it's like you're hallucinating. Um, so then it's if you retrain ResNet 50 with this new data set, you see your shape bias. You start getting a little bit closer to, you get performance closer to humans. But it is also interesting, like for some shapes it's still not able, for like an aeroplane, it's still not as good as humans. Okay. The red was the human observer performance, and um, the orange is when you train it on the stylized ImageNet, and the black is the original ResNets. It's not. So one of the questions in the chat is exactly. I think, yeah, that's exactly one way to think about it. This is not data augmentation. We don't want the model to learn texture. We want it to learn the shape. Um, and I think in the talk, the author says like, yeah, maybe it's easier for the model to learn the texture, so let's remove the texture. Right. So we don't want the model to focus on. So it's exactly what you said, Alvaro. Yep, that's it. Okay. So then, so the two things is, okay, and I think this is kind of a clever idea, right? Like, okay, I want this. This is, we see a way of how to uh, make the CNN learn something you're interested in. So maybe here it's shape, but maybe you have some other thing in your data set that you're or in your problem you're interested on. And so okay, so the two conclusions so far is CNNs mostly recognize textures, not shapes, and then if you train on a suitable data set, you can make them um, um, develop a better have a shape bias instead. So okay, we are able to do that, but then the question is there any benefit of this? Okay, is this really, is this useful in any sense? So what they did is the first row is the traditional CNN, and you have the ImageNet top one performance. So if you just took the first output from ImageNet, what was your accuracy? And if you took ImageNet top 5 is basically just if you took the top 5, uh, what is the chance, and say your input image was a dog, and what is the chance, you are correct if you get a dog in the top 5 responses. So it's pretty hard to improve ImageNet, so they still get like a zero 0.6 improvement for the top one. Um, so this is for object recognition, and there is another task called object detection, where you're not trying to say it's where you're trying to find where the object is in the image. So you're trying to put a box around the object, right? So you use some methods called Fast.AI RCNN or Fast RCNN or RetinaNet. Those are some of the methods for object detection. So you're trying to say, oh, is there a person in the image, and you try to put a box around it, and you see a significant improvement for object detection from 70. Um, and for object detection, the metric is different. It's MAP, MAP. Um, yeah. So they show there was an improvement in um, both recognition and object detection. Okay. So one of okay, if you have any questions, you can just speak up. But I don't see anything new in the chat. Okay. So now we have okay. So question is why do we? This is another interesting question. Why do we have shape bias? So here so you start on the left hand side. You see this image of a person on a bicycle, and as you move through, um, you're just adding more noise, and as you so first 4 images I can still see the bicycle. Maybe by this image there's just all noise, the last 2 images. um, so so they're trying to see, okay, why do we have a shape, why do humans have a shape bias? And they think they don't have any evidence, but they say distortion will destroy texture, but even when you add noise you might still be able to see the shape. So um, if you were trying to develop a more robust system, maybe it's better to have like give shape more importance. So again, they do like another experiment with ResNet 50, and so on the y-axis is the classification accuracy, and the x-axis is the amount of noise that's added, right? So that's the clean image, and 0.9 noise strength is, I think it's from 0 to 1. 0.9 noise strength is just a very noisy image. And you see the ResNet starts falling really quickly, right? So by zero 0.2 noise, you are below 20% classification accuracy. So let's say you collected images, right? You have your training data set that you have collected, and I don't know, you're doing driving, right? And you're trying to do automated driving, and you collect real images from, from a live stream or a video, and they might not be as clean or as uh, uh, as well created as your training data set. So you might start seeing a big drop in your test performance, right? So if you just focus on texture. um, okay, so then they tried the same things with like a bunch of people, and they see that uh, we are pretty good. So even with 0.2% noise, humans are much better than the ResNet 50 on this classification task. Um, and the question is, can we make the ResNet go more towards this red curve, right? Let me just check. Okay, fine. So this is the the ResNet. The yellow is the ResNet trained on their stylized ImageNet, and they are moving towards the human, but it's still little far away. There's still a gap. So one of So the link I shared, it has the doc, and it has his presentation, and it also has like question and answer session. Yeah, that's so one question in the chat is ResNet 50 texture biases. Yeah, it's just ResNet 50. That's right. It's just ResNet 50 um, trained on ImageNet. Yeah. So if you add little bit of noise, or your test image is change a little bit, you can see um, big drop. So one of the questions somebody asked him was like, we still have this gap, right? So his answer was, right now we have only changed the training set, right? We only made this stylized ImageNet, but we haven't. If you maybe we could do some things with the architecture. Maybe we need a new architecture for improving shape bias, and or maybe there are some other knobs like that you can train, because this is the first time we are seeing like a paper like this, um, where um, you're comparing, you're doing all these experiments in the lab and showing the same images with a large set of images to humans and the CNN. So yeah, so Abhinav, that's a good question. What type of changes to the CNN? I Yeah, maybe different kernels, maybe different number of layers. I'm not sure. We can look at the different architectures. Like if you see, um, there's one architecture called Inception, and there are a lot of things in there that I would have never thought about. Um, yeah, so I think that's still an open topic. Like, what type of architecture would work? Yeah, Jess, that's interesting too. Like he was, they think like. It's learning like local texture, like it's learning. Let me see. Yeah, they think it's somehow focusing on, when the CNN is saying cat, it's focusing on like, say, the local texture on the fur. um, and yeah, maybe if you show them enough cats, you can learn that, like, okay, cats have this kind of texture. um, And then I think that there's actually like, maybe after the talk I'll show you the paper, and there is like at least 10 different papers trying to figure this out. Like, is it shape or texture, the CNN learned? Okay, okay, let me go on. Okay, that's the benefits of shape bias, and that was, yeah, if distortions, yeah, that was the last thing we discussed. Is if you add noise, humans are still pretty good, but we are the ResNet 50 trained on the new data set, it gets a little better. Okay. So this is one part, um, I didn't fully understand. In the paper, he says like, they didn't give it like images with a lot of noise, but it was still able to be more robust to different types of noise. Um, and but the image here wasn't too helpful to me, so this is something I'll try to figure out. See if there's anything else. Right, exactly that. um, there might be more information on shape, that it's definitely possible. Okay. And let me okay, so that was the three main conclusions from the paper, that uh, because before this paper we did not know. So we know like CNNs are working really well, but for object recognition, but we didn't have like a clear evidence, like how is it learning, right? Like we were just putting the images in, and okay, we get the output. So this is the first time we see like a result like this, that it's mostly textures and not shapes. And then you can make it learn shapes if you have a data set. They have something about noise robustness. Um, let me see. Right, and yeah, that's a good way to think about it. Is just like we can think like maybe shape is a better discriminator between objects for this task. Let me see if I can share the paper. There were some interesting things. How do I new share? Oops, where did I see the paper? Okay, one sec. How do I go back to share the PDF? Okay, okay, I don't find any. I'm just trying to share the paper to show you some things about. Okay, so do you see a PDF file? Yeah. So yeah, that's the paper. It's actually surprising. Yeah, it's like 22 pages for a conference paper, which is pretty nice. Um, so this is some more motivation. Like even though we had the first successful CNN in 2012, um, we had a lot of people trying to figure out what it's doing. So this guy, Writer et al., he thought like that CNNs have a shape-like bias like children. But in this paper, it shows it's not true. Um, and this is basically the background, like why the authors were interested in this topic. Um, and so there's one group that thought it was shape before, and there's the other group here which thinks it was a texture, but they kind of answer this question. Um, okay. This was another nice thing I liked in this paper. If you see, okay, so you see. You see figure 2, right? I just want to make sure I have that. Okay. So the column, each column is like how the CNN does, and the top row is the performance of the different networks, and bottom row is the type of input, right? So even though, yeah, so from original to grayscale, the CNNs are pretty good, especially ResNet 50. So the one way to read it, this is 2012, 2013, 2014, and ResNet 50 is 2015 or 16. But if you start giving edges or anything else, you start seeing drops in the performance. Let me see what else was. And if the code is all available online for this work. Seeing if it's something. else interesting I wanted to show from the paper. Yeah, and this graphs are very, this figure is very interesting too. So like we're saying, right, like in production you might not get good quality data, right? Maybe something is, you have a, your camera has some noise, and then your test images have noise, or maybe the contrast changes, right, of your image is very possible, or there is some other type of noise. So each ABCD is a different type of noise, and the red is basically the humans, how the humans do with the different type of noise, and again the yellow is with this shape bias, right, and the black is the original ResNet 50. So what you see is like the original ResNet 50 is very susceptible to different types of noise, right? And they're trying to show, okay, how can we be more robust? And so I just showed you the noise in that slide. I just showed the noise plot, but um, for uniform noise, but then this is for contrast and different types of noise. What would happen? It's, I think it's very hard to get like a oral presentation at this conference. So you can see how much work they did to get a oral talk. Um, they have a huge appendix with, yeah, it's that many number of trials that they're running. Um, Let me see if there's anything interesting. Uh, some more images. Let me see. And this is the same plot I was showing in the presentation. Okay, so now I was trying to see if I can use this idea for a classification task, but I have not been successful, and I can show you what I did so far. Um, it's actually a Kaggle competition. Let me see which one. Oops. Yeah. So in this competition, the goal was to classify images from like it's from a museum. Okay. Um, Let me show you some images. Okay. And I'm basically, what I'm doing is I didn't write the kernels from scratch. It's um, if you have done Kaggle before, you will know there will be, whenever there's a competition, people will share some kernels for, say, like exploratory data analysis. And in this case, this is a museum of art in New York, and they have a lot of objects that have been um, categorized by a subject matter expert. Um, and there are many different labels, and it's a very unbalanced data set. So the reason I picked this to try it is there are a lot of kernels. So kernels are, somebody is written like a starter kernel, like either with Fast.ai or just a exploratory data analysis kernel. So just let me show you one of them, and I'll show you what I did. And I haven't been able to implement the idea, but I can show you what I'm trying to do. Um, so there are different images of artifacts, right? So there are paintings, I don't know, different jars, objects. Some objects are like this. They have different shapes. They're weird shapes. So some objects have like a weird height, weird width. Um, um, and so here in this one, they are trying to, um, so we are trying to apply tags to these images. Okay. Um, and then this exploratory data analysis is nice. I also use it to like learn more Python stuff because I'm more of a MATLAB person. So I'm trying to learn how to do these good plots um, with Python. Or so they are using Seaborn, so you can uh, quickly look at the code and see um, how to make these plots. Um, okay, so this is mostly for the data statistics. So they're trying to look at, okay, what is the mean value in each channel, um, and so on. Okay. So for example, you see there is some object with some writing and the image is mostly green. It's just weird. Um, and this data set, I think the training data set it has more than 100,000 images. Um, let me show you. Okay, let me show you the classification code. It's basically using Fast.ai, so something we have discussed in the previous sessions. Um, yeah, just different batch size. The size of the images are 250. I'm mostly running on the Kaggle kernels. The reason I'm doing Kaggle is because they give you a free GPU, and so for example, I have run about 6 or 7 experiments, and I can run up to. Let me see what was the last thing I ran. Your work. I'll just quickly tell you how. Yeah, see there. So 32,000 seconds. So that is how many hours? It's almost 10 hours. So 1 hour is 3,600. So 10 hours is 36,000. So I have, this. It's only one GPU, but I just let it run overnight. So these are some of the different experiments I did with different fast AI parameters. Um, okay, so what I'm trying to do is, okay, let me just show you. This is easier. Um, I'm just using ResNet 50. Um, um, similar to what Jeremy said, I'm using transformations um, for data augmentation. Um, I use the same data bunch methods for train and test split. Um, and like we discussed before, they are normalized by uh, the image stat parameters. It's because it's all transfer learning. So for my training, I have here, I remember now, okay, it's 103,000 items, right? Um, so these are some of these are some of the training images. Right? So you see, yeah, great variety. And here actually I was thinking like texture is important, but we also want to do texture and shape. Okay, so and then uh, the learner is pretty much what we have done in Fast AI. It's a CNN learner with using a ResNet 50 model, um, and I saw a lot of people, they share their kernel. So basically, I fork their kernel, and then I'm making changes to it so I can play with it. The same learning rate finders we have done before. Um, Um, that part is the same. Um, one thing, uh, maybe two things that might be new to you is one is there's test time augmentation. So test time augmentation is a really nice feature. It's like, okay, normally you just do data augmentations to your training data, right? But here I take the image of, let's say one of these guys is my test image. I do some rotation, some manipulations, and feed the same image to and then predict the output. Um, and if the model is robust enough, whatever test time augmentation I did, I should get the right output. I should get the same output. So Fast.ai has this test time augmentation feature that is already built in. So that's provided with the picture. So one thing I saw a lot of people talk about here is the metric for learning is focal loss, and I'm not too familiar with this. I don't know if somebody else has worked with this before. I can show you the code for it. Um, Here's my focal loss code. Oh, okay. It's just they just use the Fast AI version. Okay. Um, I don't know if anyone else has worked with focal loss. So they're saying like, so one of the things I read is like basically with high class imbalance, focal loss is a better choice than. So I've used cross entropy loss when I have multi classes. Um, let me see if in older version I thought I had a loss. No, sorry. I think it's just they just use the. Quickly check one more thing. And that's just when I ran it. It's just what I scored. Um, I'm actually not doing quite well. I'm like 150 out of 300. So this is not working as well as I thought. Um, Code. Okay. Sorry, that's what I was missing. I didn't see it here. Yeah. So this is how the loss function is defined. Um, I don't know if someone has worked with this before. This is the first time I've come across it. It's not. So I still don't know how to. So the talk was about like shape and texture. I still don't know how to train this. So one, okay, how to um, use that idea in this classification problem. That's what I'm still trying to do. And what other ideas I can do to improve performance. But we'll see. Yeah. This is a good competition because it's part of. It's part of a conference called CVPR. So there's no prize money. It's just it's like a learning competition. So it's pretty good. Let's see. 9:50. So actually that's all I had to share for today. I don't know if someone else has. Sure, I'll Christopher. Yeah, I'll make it public and um sure, I'll share the kernel so anybody can use it. I think it's easy to. Okay, thanks for sharing that paper. Yeah, I should take note of that. Just so actually, that's okay. Thank you. Great. That's all I have. Um, do you have anyone else wants to present or talk about any project they have? We still have some time for this.
Yeah, that's great, Doug. Thank you. I think, is anyone else got anything they want to share today? If not, we could talk about. So last week we finished the part lesson of the study group, and today we have anything in the agenda apart from the presentation. So usually we have a lesson per week. So it's just the question do we want to set up our meetups going forward? So as per meetups, we have the Americas meetup once per week. It's led by Sam. Then we have EMEA meetups also once per month, and that's led by Kai and Christian. And they usually talk about some news, like a couple of minutes, and then the main presentation is like a paper presentation, something similar that we had today. And then we have the study groups that was around the Fast.ai part 1, part 2, and then again part 1, and again part 2, and so on. And now as we finished that part 2 last week, is a question how we want to set up the study group going forward. So if anyone has any suggestions, that would be great to hear how you see this, our group developing. Couple of ideas. We could meet weekly, bi-weekly, once per month. We could start again part 1, we could start again part 2, or we could do something in between or change to different topic or something like that. Any ideas welcome.
Yeah, for me personally, if it would, like, I don't know if we can, if there's interest to start part two again, because I've been listening to part one, and part one seems so much easy. Like,
Yeah,
part one is so much easier, like,
different. Yeah,
compared to part two, and there's just so much material in part two.
yeah,
But I don't know if there's enough interest for doing part two again.
yeah. So the part 2 is going to be made available to public something around June. That's what Jeremy was saying.
Okay.
So we could potentially start that about June time again. So people that didn't have a chance to participate in the live part, we can get some new people on board, and then maybe start part 2 about June time. Possibly, that's one option. Uh, that leaves us with a couple of weeks between now and June, maybe 4, maybe something like that. So is the question also what we want to do
I
between
see.
now and June? Yeah, we could change anything. We could talk about anything. We could, yeah. And the question about additional lesson, I didn't see that one. That's supposed to be about the audio. I didn't see any information on the forums about when the audio lesson would be available. Um, Let me see at the forums, but I don't see. I would imagine that would be from Jeremy, but let me see if there's any post from Jeremy. So posted by Jeremy Howard part. I guess that will be in part 2. Where is it? Part 2. Okay, any were posted before. Okay. Sorted by the latest. NLP challenge project discussion, how to do Fast AI plans. Now, the only post I saw about some sort of kind of like plans was about the plans for the library. So they're planning to implement those improvements they identified during the part 2 course in a version 1.2. And that's most about the callbacks. They're going to implement new callback system, the new data block API, and the data augmentation, the stateful optimizer, and the NLP pre-processing. So those topics going to end up in the version 1.2, and it's going to take for them a couple of weeks to do it. But so far, I didn't about the additional lectures that they wanted to do on audio processing and some other topics. So I don't know actually when it's going to be. So we just waiting for that, and yeah. So just the question. So if anyone's got any idea or what would be interesting to do, if anything, on a weekly basis or anything other than that, we can continue that discussion in the on the Slack,
Okay.
and then yeah.
Yeah, one other interesting idea is like if you see my screen, like with the, like the old kernels, like old competitions. Um, you can. The nice thing is even the competition is over, you can still submit.
That's right.
So,
Yes.
um, but that's more like let me show you like part of this one. So this was like object detection. So they wanted to put um, so the idea would be like just doing more coding, and most of the kernels are there. So you because the hard part is getting started, like loading your images, getting everything organized, um, and then running stuff. Um, so mostly I think there is a Fast.ai kernel, or I used a lot of Keras before. Um,
Hmm.
so there is a Keras kernel. So um, you can take the kernel, basically just fork it and make your changes and run it. Um, and everybody basically, and now they improved the GPU. I think it used to be a test, NVIDIA K80,
Yeah.
and now it's like a I think one of the better ones. Um, but this is more coding, like yeah, it's like so you could
Hmm.
have like a half an hour of like learning the method, a review of the method, and then just hands-on coding, like a session if there's interest for that. Um, Basically, like we could, for example, pick a kernel, and then everybody does it, like either can do it beforehand or do it during a session. Would be,
Yeah.
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 But this guy from Switzerland is really good. His name is Kevin Made. I
Hmm.
think he's a professor in Switzerland, and he writes these. That he, um, he writes, but he writes in Keras, so the
Right. Yeah.
uh, but uh, but it's like
So you can fork his kernels and get into leaderboard quite easily. That's good.
yeah, and then now and we can, even if you take like a completed competition. Um, um, yeah, and it's his kernel will be like you will not get in the top 10%,
Mhm.
but at least you just get started. Most of the times for me it's
Yeah.
been just organizing this data, um, and getting it to train and test split. Um,
Hmm.
yeah.
Yeah. So
So
we have also a question on the chat about um, doing a session about how to start on Kaggle. So like if someone is new to Kaggle platform, we could do a session on how to do it, that's for sure.
okay, yeah,
And there is another op suggestion that we could have a presentation on deploying models,
oh yeah,
25th of May, so that's in 2 weeks' time.
yeah, that would be great too.
So, okay, we can. we can get a agenda, things like that.
Yeah.
So at the moment, it seems like we have the 25th of May. So maybe we can do things like that. So if anyone wanted to present anything, we could use that time slot we have on Saturdays, 9 a.m. Pacific, which seems to work for everyone. And if we have any topic on the agenda, then we do the meeting. If there is anything to talk, then we just don't do it. So let me try to create some sort of like a calendar with meetings we have planned so far, which at the moment will be the deploying deep learning models in 2 weeks. And if anyone wants to do the how to start in Kaggle presentation, that also will be great.
Yeah. I can do that.
You can do that?
Yeah, I
Okay.
can do that.
Fantastic. Thank you.
Yeah.
That would be nice.
Yeah. I can. I did a couple.
Okay. Sounds like we have two already
Yeah.
meetups, so that's great. That's fantastic. Okay, so it seems like we will just continue with those weekly meetups as long as we have ideas for the presentation. That's great. That's great.
Yeah.
And then I guess that's only a suggestion. If we want to do the part two is available to the public, and then get some more people on board with part two. That we can do that as well.
So I know Daniel did like this quick overview of full stack deep learning, but I thought it would be interesting to maybe, I started watching those videos. I thought it would be interesting to discuss maybe them in details and like have questions and answers on those videos.
Yeah.
That's, but I don't know if like how many people would want to do that.
Yeah, that's something. This course is also on my list to do. It seems like interesting course, or yeah. So we could do that as well. They have like 12 videos or something like that, right? So
Yeah.
that's going to take some time, but
and you need to like, I think you need some sort of a deployment platform. So
right.
either like I think they use Google GCP by default.
Right.
But,
yeah. Yeah, we could do that as well. So that's a good idea. So for that, we would need to plan like 3 months or something. If it's one video per week, that's going to take a while. That's okay.
They're much easier. They're like, I think those videos are much easier than Fast.ai. At least
Okay.
like, I think it's all about actually like, working with code and implementing it.
Okay. Yeah. So yeah, that's right. So someone was asking what sort of videos. This is the full stack deep learning, where they talk about. They have actually nice. They have videos and the presentation available, and it happened in March this year, so it's quite recent.
And they have a GitHub also.
Okay. Yeah, that's right.
With problems, and another one with another directory with solutions.
Oh, that's great, and it's all free as well, so it's fantastic.
Yeah.
And they have this one slide when they show all the deep learning kind of ecosystem, we call like that. And the thing that Jeremy teaches us is just like one bit of the big picture, and there's actually a lot more to that. It's how we deal with the data, how we version the data, how we load the data, how we keep the data, how we get the data, and then we, I guess, do some exploratory data analysis with. Do they talk about this? I hope so.
No, I'm not.
No.
I don't remember it, but I got it like third or fourth lecture.
Okay. And then, of course, you create a model and you train a model. But then the next step, of course, if you test your model, and then you deploy your model, then you maintain your model. I guess they also talk about testing. So the scope of that course is quite nice. So we could do that. We could do that on a weekly basis, and it's going to take a while, but that's fine. So what we could do, I could create some sort of calendar with the agenda items for each week, and then we'll just ask people to volunteer to present anything, and then we'll go from that, I guess.
Sounds good.
Also looking at
Sounds
the
good.
chat if there's anything. Yeah.
Yeah, the full stack deep learning will be good. Yeah, that's a good idea. Because we just learned the algorithms part, but there's a whole,
Yeah,
like you said, there's a whole ecosystem.
there's more than that.
Yeah,
And that depends what you want to do. Someone like Jeremy, he's interested in kind of research of deep learning models, making them fast and so on. But I guess more reward problems. There's also the deployment part and so on, so on. And I would imagine in kind of like bigger organization, there will be multiple roles, like in the data scientist roles, when some people work on algorithms, some people would work on deployments, some people would work on testing, and so on, so on. But at least I think it's good to know what are those tasks are to kind of get the deeper understanding of the full spectrum. And I was listening to a podcast with a guy from a company called Stitch Cheeks. What they do, they have some sort of business model where they ship a a box with some clothes to customers, and the clothes are selected by machine learning model. So they have customers in a database. The machine learning model picks some like a fashion clothes or whatever, some clothes. They send them to customers, and then if they like them, they keep them and they pay for those, of course. If they don't like those clothes, they send them back. So they have like a feedback that costs them money. If the model is wrong, that costs them money because people didn't like what was provided to them. So they send them back, and they have to keep them in a warehouse or whatever. So that's what I do. And what they suggest they do, they have like a full stack deep learning guys. So they don't have those, although it's quite a big company, but they don't have those specific roles, like someone only does models, someone only does deployment. They have like a full stack guys, and they believe that this kind of good for, and it also was good for them because people don't need to wait. So someone who's deploying the models don't need to wait for someone who's creating the model. So the one person can do everything. So I think that was quite that. I've sent message to this guy asking for like what sort of maybe training they have for those people. How do they train them to become like do all of that? But I didn't get any response. But I think this full stack deep learning is about something like that. So yeah, okay, let's do that then.
yeah.
Fantastic.
And in my company, I have a small experience. Like we've been most like my boss has been asking me to like look into Amazon SageMaker, um, because most of what we are doing in we do medical imaging, and we're mostly using Amazon. And right now, so for example, I start an instance. I will have to like copy the data there. Um, I have like a particular format called DICOM, so I have to convert it to PNG so that these Fast.ai or different models can use it. But SageMaker is supposed to like something to help the like deep learning developers also for training and then deployment also. But maybe full stack will
Mhm.
cover it. Yeah.
Yeah, SageMaker has got quite a lot of. I looked at that, and indeed they have a lot of ready for you. So like, you don't necessarily need to know how to create different models if you can use existing one.
I see. We've been training too, so we can start a Jupyter notebook, and on our instance, and then they because we have the weight, right, like the weights. So the question is where to save the weights so I can deploy it in production, and they make it easy to save weights and then run inference. But
Mhm. Also, I think the SageMaker, they also have nice idea that they have, you can start your notebook on a CPU only instance, which doesn't cost a lot of money, and then
right,
from that CPU instance, you can start using some SageMaker code. You can start like a parallel instances only for training with the GPU. You can start multiple GPUs if you have trained a lot of images. But your main, and then once you finish training, that GPU virtual machine is going to automatically stop. So you don't have to pay for that. You only pay for that if you need it. So I think that's also quite interesting what they have there.
yeah,
Okay, excellent. Is there anything else from anyone? Yep. So that's great. So let me create that calendar with some dates, and then I'll put that on the Slack, and then people can put the names, and we can start with the full stack and with the Kaggle, how to start in Kaggle session, and then we have the 25th of May, the deployment session. It's nice, excellent.
yeah, that'll be great.
Okay, thanks everyone for joining today. Thanks, Mehul, for presentation.